Analyzing forensic hair and fiber evidence using mass spectrometry. Analyzing forensic hair and fiber evidence using mass spectrometry. Forensic investigations play a crucial role in criminal justice, helping to solve perplexing crimes by gathering and analyzing evidence. One valuable and frequently encountered type of evidence is hair and fiber samples. The analysis of such samples has traditionally been a challenging task due to the limited information they provide. However, advancements in technology, particularly in the field of mass spectrometry, have revolutionized the way hair and fiber evidence is examined. In this article, we will explore how mass spectrometry is utilized to analyze forensic hair and fiber evidence. Hair and fibers can provide significant clues about a crime scene, linking suspects to victims or objects involved. The analysis of these materials involves the identification of specific characteristics, such as the type of hair or fiber and its potential sources. Mass spectrometry, a powerful analytical technique, enables investigators to obtain detailed information about the chemical composite ion of hair and fibers, aiding in the identification process. Mass spectrometry involves ionizing the sample, separating the ions based on their mass-to-charge ratios, and detecting the ions to generate a mass spectrum. This spectrum provides information about the molecular composition of the sample, allowing forensic scientists to identify distinctive features. When applied to hair and fiber analysis, mass spectrometry can reveal essential details such as chemical markers, contaminants, and environmental exposure. One application of mass spectrometry in hair analysis is the identification of drugs or toxins. Hair samples have a remarkable ability to retain chemicals that an individual has been exposed to over a prolonged period. By utilizing mass spectrometry, forensic scientists can detect the presence of illicit drugs, pharmaceuticals, or environmental pollutants in the hair shaft. This information can provide valuable insights into an individual's habits, lifestyle, or even involvement in criminal activities. Another aspect of hair analysis is the determination of the origin of hair, which can assist in identifying potential suspects or establishing whether two individuals may be related. Mass spectrometer can be used to examine isotopic ratios, which can vary depending on geographic location, diet, or other factors. By comparing the isotopic ratios of the hair sample with databases or reference samples, forensic experts can potentially narrow down the origin of the hair, aiding investigations. Fiber analysis is another area where mass spectrometry has proven invaluable. Fibers can be found at crime scenes, connecting suspects or objects to specific locations or incidents. Mass spectrometry enables the identification of the chemical composition of fibers, helping to differentiate between natural and synthetic fibers and narrowing down potential sources. This information can link a suspect to a particular location or establish a connection between multiple crime scenes. In addition to identifying the chemical composition of fibers, mass spectrometry can also help determine the type of textile or material present in a fiber sample. Certain fibers, such as carpet fiber, RS or clothing fibers, have distinct chemical markers that can be identified using mass spectrometry. This information can provide critical forensic evidence, linking suspects to specific objects or locations. Moreover, mass spectrometry can aid in the analysis of fiber transfer patterns. When a fiber is transferred from one surface to another, it can provide essential information about the movements and interactions between individuals, objects, and crime scenes. By analyzing the chemical composition of transferred fibers using mass spectrometry, forensic scientists can establish potential links between different locations or individuals. Mass spectrometry has been a game changer in the field of forensic science, specifically in the analysis of hair and fiber evidence. Hair analysis using mass spectrometry has proven especially useful in detecting the presence of drugs or toxins. This information can be pivotal in understanding an individual's habits, lifestyle choices, or potential involvement in criminal activities. Another essential aspect of hair analysis is determining the origin of hair samples. Mass spectrometry enables scientists to examine isotopic ratios, which can vary based on factors such as geography, seed location, or diet. Fiber analysis is another area where mass spectrometry has proven its worth. Fibers found at crime scenes can be crucial in linking suspects or objects to specific locations or incidents. Mass spectrometry allows for the identification of the chemical composition of fibers, helping to differentiate between natural and synthetic fibers and narrowing down potential sources. This information is vital in connecting suspects to particular locations or establishing links between multiple crime scenes. In addition to identifying the chemical composition of fibers, mass spectrometry can also determine the type of textile or material present in a fiber sample. Different fibers, such as those found in carpets or clothing, have distinct chemical markers that can be identified through mass spectrometry. This information provides critical forensic evidence, linking suspects to specific objects or low cations involved in criminal activities. Furthermore, mass spectrometry plays a crucial role in the analysis of fiber transfer patterns. When fibers are transferred from one surface to another, they can offer essential insights into the elements and interactions between individuals, objects, and crime scenes. In summary, mass spectrometry has revolutionized the analysis of hair and fiber evidence in forensic investigations. As technology continues to advance, mass spectrometry will undoubtedly play an increasingly significant role in solving complex criminal cases and ensuring justice is served. Furthermore, mass spectrometry has also proved useful in the analysis of dye and pigment particles found on hair and fibers. This can be particularly helpful in cases involving counterfeit products are determining whether a dye or pigment is consistent with the claimed origin or brand. Additionally, mass spectrometry has been crucial in the analysis of trace elements present in hair and fibers. Trace elements, such as metals or minerals, can originate from the environment or the individual's diet and can leave distinct signatures in the sample. The advancements in mass spectrometry techniques have also facilitated the analysis of post-mortem hair and fiber samples, which can provide crucial evidence in cases involving suspicious deaths. By analyzing the chemical composition of these samples, forensic scientists can determine whether any drugs, toxins, or poisons were present in the individual's system at the time of death. This information can shed light on the cause of death and potentially lead to the identification of the responsible party. Furthermore, the ability of mass spectrometry to detect and identify minute amounts of substances has opened new possibilities in the analysis of trace amounts of hair or fiber samples. Even in cases where a sample is minimal or deteriorated, mass spectrometry can provide valuable insights into its composition. This can be particularly significant in cold cases or situations where traditional analysis methods may have been inconclusive. This allows for the visualization of individual components within the sample, providing additional information about its structure, composition, or any abnormalities present. The combination of mass spectrometry with imaging techniques enhances the overall analysis and interpretation of hair and fiber evidence, providing a more comprehensive understanding of the sample. The use of mass spectrometry in analyzing hair and fiber evidence in forensic investigations has significantly advanced our understanding and capabilities in solving crimes. When applied to hair analysis, mass spectrometry can detect the presence of drugs, pharmaceuticals, or environmental pollutants that an individual has been exposed to over time. This information can provide valuable insights into an individual's habits, lifestyle, or potential involvement in criminal activities. Furthermore, mass spectrometry allows for the determination of the origin of hair by examining isotopic ratios. Fiber analysis is another area where mass spectrometry proves invaluable. By identifying the chemical composition of fibers, mass spectrometry helps differentiate between natural and synthetic fibers. Narrowing down potential sources. This information can link a suspect to a particular location or establish connections between multiple crime scenes.